The data collector is used to extract data from data files and build a bolt hole pattern project. Use the Configure button to access tools to set up the data collector, and the Play button to execute it. Think of the data collector as a template. The template describes the name of the file, where it expects to see the file, and the contents, so it knows where each hole is located at with regards to the data file. Once that's complete, you simply select the Play button to execute the data collector and build the bolt hole pattern project. I'm going to open a solution that has a data collector configured and ready to go. I'm going to go to File, and I'm going to go to Recent and click on the BPA example. Now you'll notice the Play button is illuminated. That's telling us that there's a data file out there, and I'm ready to play the data collector to extract and build the bolt hole pattern project. So I click on the Play button. It's asking me how many parts I want to use in the analysis. I'm going to say 5. And you'll notice I've got pattern 1 and pattern 2, hole pattern 1 and hole pattern 2. So the data collector worked. It opened up the file, extracted the information it needed to build the bolt hole pattern project. It's important to note that a solution contains a project and a data collector. They're two separate entities that exist inside a solution. If you want, you can go to File, New, and you can erase the project and leave the data collector intact, or vice versa. Let's look at the data collector configuration for this solution. When I click on the Configure button, a window appears. You'll notice buttons on the left-hand side to aid in the configuration. This describes the objects that contain how to read the data from the file and where the hole locations are at. This section here will actually show you the data. This section up here will give you the properties for the object. So if I click on data source, for example, you'll notice I can change the properties for this setting. I think the best way to learn how to configure the data collector is to do it from scratch. So let's clear this and open up a new solution. We need some data to work with. I'm going to use QC Calc Real-Time and a data simulator to simulate measuring a part on a CMM. If I click on this button, it will be as if I measured a part on a CMM. QC Calc Real-Time is configured to automatically export data to the bolt pattern analysis software. So if I click on Inspect, it'll automatically export data to a data file that we could use to generate the data collector. And then of course you'd use the data collector to pull that data in. So I'm going to click on the Inspect button. Data goes into QC Calc Real-Time, and now we have a data file to work with. I'm going to click on the Configure button, and I'm going to expand this to take over the whole screen. Now the first thing I want to do is tell it where the data file is and read it in. To do that, I'm going to click on the data source item here. Click on that. You notice this updates itself. I'm going to choose the type of data. I'm going to choose ProLink Export after version 3.4.82, Becker Quality Solutions, the bolt pattern analysis. I know there's a data file out there that we could use that follows that the properties and settings accordingly. So I'll use the Browse button. I'll browse to where that file is located. It's in the repository right here. I'll click on that file, click on Open. Then I'll click on the Import Data button to actually read in that data file. Now you'll notice some of the rows are green, some of the rows are clear, or are white, I should say. The green rows represent header records or header information. The white records represent part data. You notice we had nominal, plus tolerance, minus tolerance, and then the data. So you'll use this information to figure out how to configure your data collector. The next step is to add a pattern. To do that, I'll simply click on the Add New Pattern button here. You'll notice the pattern is added to this list here. You also notice this changed. You're now in a mode where I can identify each individual hole in the pattern. If I expand this, you notice I've got display and coordinate system. I can change the display to change the scaling, the percent of tolerance. I can include an origin, part coordinate axis, world coordinate axis. If you want, you can change the coordinate system, flip the x-axis, flip the y-axis. These are different ways to customize how you're viewing the data and the coordinate system that are used. You want to make sure the coordinate system matches your machining process. So you can do that using the properties for the pattern. I'll click on the pattern object here, and that'll put you into a mode where I can identify where the whole information is in the table. You'll fill this information out and click on the Add Feature, and it'll add that feature object to the pattern. So you have to identify where the X and Y nominal cell locations are, the true position cell location. You can optionally put in a diameter plus nominal plus or minus tolerance, as well as the X actual column, the Y actual column, and optionally the diameter actual column. So it's really pretty simple. You just click on the cell you want to fill in. In this case, I'm clicking on the X nominal. Then I'll click on the cell in the table which contains that information. You'll notice it identifies the cell location. Go to the Y, click on the Y nominal, go to the true position plus tolerance, click on the true position plus tolerance in the table. Notice as I fill this information out, your X actual and Y actual column identification is added to it as well. Then if I want, I can add the diameter. So I'll click on this, slide over, click on the diameter nominal, and it'll fill out the plus and minus tolerance. Once you're done with this, you can identify whether it's an inner diameter, or you can use linear tolerances if you want. And when you're done, you just click on Add Feature, and it'll add that feature to your pattern. Since this data came from QC Calc Real Time, I know that it contains the nominal and plus tolerance information as well as the part data. In some instances where you may not be using QC Calc Real Time, you may use some other application to get the data, the nominal and plus tolerance information may not be included. In those instances, you can manually enter in the nominal and plus tolerance, the nominal and plus tolerance values, and then you'll just tell it where the columns are that contain the information, and then you can do it that way as well. Let's add the additional holes in this pattern. So I'll click on the X. Let's go to hole number 2, which would be here. So I'll click on this. Now a shortcut to speeding up this process, if you click on the X, hold the control key down, then I can just move to the Y nominal, then the plus tolerance cell, and then click on the nominal diameter, and it'll fill all that information in. I'm already at an inner diameter. This is an inner diameter. I'll click on Add Feature, and I'll just keep going to do the rest of the pattern. It's really pretty simple. It's just point and click. So we've created pattern 1, and that pattern contains 6 features. Let's add another pattern to this project, and instead of using the true position tolerancing zones to control the hole locations, we'll use the linear tolerancing zones. So I'm going to click on Add New Pattern. You notice down here it added a second pattern, and now we're in a mode to go ahead and add new features. I'm going to go through the same process as before. However, this time I'm going to check on the Use Linear Tolerance Zones, and now I'll just click on the X, click on the X nominal, hold the Control key down, click on the Y, and then click on the diameter, add new feature, go to the next one, and the next one, the next one, and finally hole number 6. In this example, I've been including the diameter information, which is optional. What the bolt pattern analysis will do is it will figure out what the minimum maximum material condition is for the hole, and that minimum maximum material condition will be used in the calculation. So if I've got 15 parts, for example, and I'm looking at the hole 1 true position, it'll go through all of the diameters of hole 1, figure out what the minimum maximum material condition is, and that's the value it uses for the calculations. To complete the data collector, we have to decide how many parts we want to use in the analysis, and do we want to keep the data file after it's been read and the bolt hole project has been built. If you click on the Set Number of Parts button here, that'll bring up a window which will let you set how many parts to use. You can use all the available parts that are in the data file. You can ask the operator, which that's what's set to now, or you can select a fixed number. If you select a fixed number, and I put in 100 parts, for example, and you don't have 100 parts, it's going to use as many parts as it can to reach that amount that you've chosen. Let's leave it to ask operator. If I want to delete the source file, I'll just check the delete imported files checkbox here. I'm going to leave that unchecked for now. If you want to make changes to either one of these patterns, maybe you want to change the name of the pattern or maybe change the name of the feature, you just simply click on the pattern and then you can change the name here, or you can click on the feature, change the cell if you need to, or change the data here, click on update, and it'll update the properties for that particular object. Well, our data collector is complete, so let's go ahead and play it. I'll exit this window. The data collector is done. I didn't lose anything. It's saved in it's in memory. If I hit the play button here, it'll actually play the data collector. Since the data file is identified, there's something to process. This is illuminated. I'll click on the play button. It'll ask us how many parts we want to use. Well, we only have 2 parts in the file, so I'll say OK. And it built our project. We have pattern 1, which is using the true position tolerancing zone, and we have pattern 2, which is using the linear tolerances. So our data collector did exactly what we wanted it to do. Once the data file has been read and the information extracted and the bolt hole pattern built, you really don't need the data file anymore. So you can set your data collector so that it actually deletes the data file. If you check delete imported files and play the data collector, it'll ask us if you want to clear the project. You'll say yes. How many parts you want to use? 2. I'll say OK, and it'll build the project. Notice the play button is no longer illuminated, but that's because the data file was deleted. Let's pull up QC Calc Real Time and the training CMM and measure another part and watch what happens. Notice the play button is now illuminated. We can go ahead and hit the play button to run the data collector. Now we have 3 parts instead of 2. I'll use all 3. And you can see it's working. So you can also use this play button as an indicator to let you know that, hey, there is new data there, and you can go ahead and play it.